Chapter 3 of The Romance of Plant Life. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Romance of Plant Life by George Francis Scott-Elliot. Chapter 3. A Tree's Perilous Life. Hemlock, spruce, and pine forests. Story of a pine seedling. Its struggles and dangers. The gardener's boot. Turpentine of pines. The giant sawfly. Bark beetles. Their effect on music. Storm and strength of trees. Tall trees and long seaweeds. Eucalyptus, big trees. Age of trees. Venerable sequoias. Oaks, chestnuts, and olives. Baobab and dragon tree. Rabbits as woodcutters. Fire as protection. Sacred fires. Dugout and birch bark canoes. Lake dwellings. Grazing animals and forest destruction. First kind of cultivation. Old forests in England and Scotland. Game preserving. The murmuring pines and the hemlocks stand like harpers hoar with beards that rest on their bosom. Longfellow. Of course, the hemlock here alluded to is not the hemlock rank growing on the weedy bank, which the cow is adjured not to eat in Wordsworth's well-known lines. If the animal had, however, obeyed the poet's wishes and eaten mellow cow's lips, it would probably have been seriously ill. The hemlock is the hemlock spruce, a fine, handsome tree, which is common in the forests of eastern North America. These primeval forests of pine and fir and spruce have always taken the fancy of poets. They are found covering craggy and almost inaccessible mountain valleys. Even a tourist traveling by train cannot be but impressed by their somber, gloomy monotony, by their obstinacy in growing on rocky precipices, on the worst possible soil, in spite of storm and snow. But to realize the romance of a pine forest, it is necessary to tramp, as in Germany one sometimes has to do, for 30 miles through one unending black forest of coniferous trees. There are no towns, scarcely a village or a forester's hut. The ground is covered with brown, dead needles, on which scarcely even green moss can manage to live. Then one realizes the irritating monotony of the branches of pines and spruces, and their somber dark green foliage produces a morose depression of spirit. The conifers are, amongst trees, like those hard-set, gloomy, and determined northern races whose life is one long continuous strain of incessant endeavor to keep alive under the most difficult conditions. From its very earliest infancy, a young pine has a very hard time. The pine cones remain on the tree for 2 years. The seeds inside are slowly maturing all this while, and the cone scales are so welded or soldered together by resin and turpentine that no animal could possibly injure them. How thorough is the protection thus afforded to the young seeds can only be understood if one takes a 1-year-old unopened cone of the Scotch fir and tries to get them out. It does not matter what is used. It may be a saw, a chisel, a hammer, or an axe. The little elastic, woody, turpentiny thing can only be split open with an infinite amount of trouble and a serious loss of calm. When these 2 years have elapsed, the stalk of the cone grows so that the scales are separated, and the seeds become rapidly dry and are carried away by the wind. These seeds are most beautiful and exquisitely fashioned. The seed itself is small and flattened. It contains both resin and food material, and is enclosed in a tough leathery skin which is carried out beyond the seed into a long, very thin, papery wing, which has very nearly the exact shape of the screw or propeller of a steamer. This wing or screw is intended to give the seed as long a flight in the air as possible before it reaches the ground. If you watch them falling from the tree, or throw one up into the air and observe it attentively, you will see that it twirls or revolves round and round exactly like the screw of a steamship. It is difficult to explain what happens without rather advanced mathematics, but it is just the reverse of what happens in the steamer. The machinery in the steamer turns the screw, and the pressure of the water, which is thrown off, forces the boat through the water. In the case of the pine seed, the pressure of the air on the flying wings makes the seed twirl or turn round and round, and so the seed must be a much longer time in falling. They often fly to about 80 or 100 yards away from the parent tree. Once upon the ground, the seed has to germinate if it can. Its root has to pierce the soil or find a way in between crevices of rocks or sharp-edged stones. All the time it is exposed to danger from birds, beasts, and insects, which are only kept off by its resin. But it is difficult to see, for its color is just that of dead pine needles, and its shape is such that it easily slips into crevices. Then the 7 or 8 small green seed leaves break out of the tough seed coat, and the seedling is now a small tree 2 inches high. It may have to grow up through grass or bramble, or through bracken, which last is perhaps still more dangerous and difficult. It will probably be placed in a wood or plantation where hundreds of thousands of its cousins are all competing together. "In this case, the struggle for life is intense. Each tree, seeking for sunlight, tries to push its leader shoots up above the general mass of foliage, but all are growing in height, whilst the lateral branches, which are cramped by the neighboring trees, are continually thrown off. The highest branches alone get sufficient light to remain alive, but they cannot spread out freely. They are strictly limited to a definite area. The crown is small and crowded by those of the trees next to it, and the trunk is of extraordinary length." The above quotation from Albert Franz's Silviculture (Paris, 1903) refers to an artificial forest cultivated and watched over by man. But the trees in such forests have extra dangers and difficulties to fight against. Even scientific foresters admit that they are very ignorant of what they are trying to do. In fact, the more scientific they are, the more readily they will confess how little they really know. Watch a laborer in a nursery transplanting young pine trees. Each seedling tree has a long main root, which is intended to grow as straight down into the ground as it possibly can. All the other roots branch off sideways, slanting downwards, and make a most perfect, though complicated, absorbing system. With his large hand the man grasps a tree and lifts it to a shallow groove which he has cut in the soil. Then his very large, heavy-nailed boot comes hard down on the tender root system. The main root, which ought to point down, points sideways or upwards or in any direction, and the beautifully arranged absorbing system is entirely spoilt. The wretched seedling has to make a whole new system of roots, and in some trees never recovers. All sorts of animals, insects, and funguses are ready to attack our young tree. Squirrels in play will nibble off its leading shoots. Cattle will rub against its bark, and the roe deer, a very beautiful creature, and yet a destructive little fiend from the tree's point of view, nibbles the young shoots and tears the bark with its horns. A tree's life is full of peril and danger, yet it is most wonderfully adapted to survive them. Take a knife and cut into the bark of a pine tree, and immediately a drop of resin collects and gathers on the wound. After a short time this will harden and entirely cover the scar. Why? There are in the woods, especially in Canada and North Russia, hundreds of insects belonging to the most different kinds, which have the habit of laying their eggs in the wood of tree trunks. In those regions the entire country is in the winter covered with snow and ice for many months. Insects must find it difficult to live, for the ground is frozen to a depth of many feet. Where are the eggs of these insects to be stored up so that they can last through the winter without injury. There is one insect at least, or rather many, of which the giant sawfly may be taken as an example, which have ingeniously solved this problem. She painfully burrows into the trunk of a tree and deposits her eggs with a store of food at the end of the burrow. A drop of resin or turpentine, which would clog her jaws, makes this a difficult task, but, as we find in many other instances, it is not impossible, but only a difficulty to conquer. If it were not for the resin, trees might be much more frequently destroyed by sawflies than they are. The larva of the sawfly is a long, fleshy maggot. Just at the end are the strong wood-cutting jaws by which it devours the wood and eats its way out as soon as it feels the genial warmth of spring penetrating through the tree bark. Many other insects hibernate or lay their eggs in tree trunks. Some are caterpillars of moths, such as the well-known goat moth. Others are beetles, such as one which burrows between the bark and the wood of apple trees. The mother beetle lays a series of eggs on each side of her own track. Each egg produces a grub, which eats its way sideways away from the track of the mother. The track made by these grubs gets gradually wider because the maggots themselves grow larger and more fat with the distance that they have got from their birthplace. We shall find other instances of burrowing insects when we are dealing with rubber plants. This resin or turpentine is a very interesting and peculiar substance, or rather series of substances. It is valuable because tar, pitch, rosin, and colophony are obtained by distilling it. When traveling through the coast forests of pine trees in the Landes of western France, one notices great bare gashes on the stems leading round and down the trunk to a small tin cup or spout. These trees are being tapped for resin, from which rosin is manufactured. It would be difficult to find any obvious connection between music and the giant sawfly. Yet the rosin used by Paganini and Kubelik has probably been developed in conifers to keep away sawflies and other enemies. This very district, the Landes in France, was once practically a desert, and famous as such in French history. The soil was so barren that no villages or cultivation were found over the whole length of it. Now that it is planted with trees which are able to yield firewood and rosin, it is comparatively rich and prosperous. Storms are also very dangerous for tree life. One can only realize the beauty of a tree by watching a pine or ash in a heavy gale of wind. The swing of the branches, the swaying of the trunk, the balancing support of the roots which, buttress-like, extend out into the soil, give some idea of the extraordinary balance, toughness, and strength in trees. Except in the case of the common umbrella, which is an inefficient instrument in high wind, engineers have never attempted the solution of the problem satisfactorily solved by trees. A factory chimney only 51 feet in height will have a diameter at the base of at least 3 feet. This means that the height is about 17 times its diameter. But the rye plant, with a diameter at base of 3 millimeters, may be 1,500 millimeters high. That is, the height is 500 times its diameter, and the rye plant has leaves and grain to support as well as its own stem. In pine forests on exposed mountainsides there is almost always at least a murmuring sound, which, in a storm, rises into weird howls and shrieks. With Greek insight and imagination, the ancients supposed that spirits were imprisoned in these suffering, straining pines. That is most beautifully expressed in The Tempest, where the dainty spirit Ariel had been painfully confined in a pine tree for a dozen years, and "his groans did make wolves howl and penetrate the breasts of ever angry bears." End quote. One of the most interesting points in botany depends on the fact that evil conditions of any sort tend to bring about their own remedy. Endymion's spear was of "toughest ash grown on a windy site." Keats. The prosaic chemical analyses of German botanists have, in fact, confirmed the theory there suggested, for it is found that the wood of trees grown in exposed, windy places is really denser and tougher than that of others from sheltered woods. If one realizes all these dangers from insects, animals, and storms, the height to which some trees grow and the age to which they live become matters for astonishment and surprise. The tallest trees in the world are probably certain eucalyptus of Australia, which have obtained a height of 495 feet above the ground. They are by no means the longest plants, for there are certain ratans or canes, climbing plants belonging to the palm family, which may be 900 feet long, although their diameter is not more than 2 inches. There are also certain seaweeds in the Southern Ocean off the coast of Chile, which attain a prodigious length of 600 feet. Macrocystis pyriferus, or kelp. That is not so remarkable, for their weight is supported by other plants in the case of the rattans, and as regard the seaweeds, by the water in which they float. The next in order to the eucalyptus are those well-known mammoth or big trees of California, Sequoia gigantea. They grow only in certain valleys in the Sierra Nevada at an altitude of 5,000 to 8,000 feet. Their height is usually given as from 250 to 400 feet, and the diameter sometimes exceeds 35 feet. Since they have become a center of the tourist industry in the United States, various methods have been adopted to make their size more easily realized. Thus, a coach with 4 horses and covered by passengers is, or used to be, driven through a gateway made in one of them. The trunk of another has been cut off some feet from the ground, and a dancing saloon has been made on the stump. It is at least doubtful if dancing would be very agreeable upon such a cross-grained sort of floor. A complete section of one of them was carried across the United States to make a dining-room table for an American millionaire. The age of one of these trees has been estimated at 3,300 years. That is to say that it was a seedling in 1400 B.C. and has been peacefully growing in a Californian valley during all the time when Greece, Rome, Spain, France, Britain, and of course the United States developed their civilizations. The specimen of the mammoth tree in the Natural History Museum in London was 1,335 years old. The possible age of many of our common trees is much greater than anyone would suppose. The Jupiter oak in the forest of Fontainebleau is supposed to be 700 years old. Another oak, which was cut down at Bordia in the Baltic provinces of Russia, was supposed to be about 1,000 years old. Other millennial trees are or were another oak and 2 chestnuts. The oak grew in the Ardennes. The chestnuts still flourish. One at Sancerre, France, and the other the famous specimen on Mount Etna. There are also 8 olive trees in the Garden of Gethsemane at Jerusalem, which are certainly 1,000 years old and were, according to tradition, in existence in the time of Jesus Christ. And yet all these trees are mere infants compared to Adamson's baobab and the dragon tree of Orotava. The celebrated traveler alluded to visited the Cape Verde Islands in 1749 and found inscriptions made by English travelers on the trunk 300 years before his time. From the growth since then, he calculated that some of these trees were about 6,000 years of age, and they were 27 feet in diameter. The record is held by the dragon tree of Orotava in the Canary Islands. When the Spaniards landed in Teneriffe in 1402, its diameter was very nearly 42 feet. It was, however, greatly injured by a storm in 1827, and finally destroyed in 1851. The wood was then made into walking sticks and snuff boxes. The age has been estimated at 10,000 years, or by other authorities at 8,000 years only. The dragon's blood of the Canaries, a well-known remedy in the Middle Ages, was not, as is popularly supposed, derived from this tree, but was obtained from a totally different plant. But there is a hazy tradition to the effect that the story of the dragon, which guarded the golden fruit in the island of the Hesperides, was nothing but a garbled account of this redoubtable veteran of the plant world. There is no particular advantage in growing to these enormous heights and clinging to life in this way for hundreds and thousands of years. Nature seems to have found this out, and preferred the ordinary pines, oaks, and larches, which are mature in a few hundred years. In 1,000 years, 10 generations of larch or pine can be produced, and, as each is probably better than its predecessor, a distinct improvement in the type is possible. All these long-lived giants belong, in fact, to the less highly specialized orders of plants. They are like the primeval animals, the mammoths, Atlantosauri, and saber-toothed tigers. Yet, when we come to think of the many and diverse perils to which trees are exposed, the existence of even these exceptional monsters seems very wonderful. After a violent storm which had blown down many of the trees in a friend's park, I visited the scene of destruction, and discovered what had apparently, in almost every instance, produced it. Rabbits had overthrown these trees. They had nibbled away part of the cork and part of the young wood on the projecting buttress-like roots at the base of the tree. In consequence, water, bacteria, and fungus spores had entered at the injured places, and part of the roots had become decayed and rotten. When the gale began to sway them backwards and forwards, and a severe strain came on what should have been a sound anchoring or supporting buttress, the rotten part yielded, and these fine, beautiful trees fell a prey to the rabbit. The influence of forests and timber on the daily life of mankind is a most romantic and interesting chapter in history. Every savage tribe, every race of man, however degraded or backward, is acquainted with fire. Fuel is, therefore, a necessity of existence for all savages, and not merely for cooking. There is a very interesting passage in London's The Call of the Wild, when the dog Buck, in his dreams, remembers a hairy man crouching over the fire with Buck's ancestor at his feet, whilst in the darkness all round them the firelight is reflected from eyes of wolves, bears, and even more terrible and dangerous brutes which have now happily vanished from the world. For protection at night, fire was an absolute necessity. Even at that long distant period, therefore, man had commenced to attack the forest. Unless one has had to tend a wood fire for 12 hours, it is difficult to realize what a quantity is required. To prepare fire was a long, laborious, and difficult operation. One piece of wood was placed on the ground and held in position by the toes. A pointed stick was taken between the two palms of the hand and twirled vigorously round and round until the heat was enough to ignite a piece of rotten wood placed as tinder. Therefore smouldering branches were kept always burning, as they are today amongst the Fuegians and some other savages. It was a sacred duty to watch this fire, and the woman, usually old, who was entrusted with the task, was very probably put to death if she failed. From this very ancient savage custom probably arose the cult of the Vestal Virgins in ancient Rome. Another very important factor in savage life was the canoe, or pirogue, necessary for fishing or to cross lakes and rivers. The first shanty of Rudyard Kipling has a probable theory, and is a beautiful account of how man first thought of using a floating log. They hollowed out the log and dug out the canoe by first lighting a fire on it and then scraping away the cinders. Then the sides were pressed out, and it was trimmed and straightened to the right shape. All this was the idea of some Paleolithic genius far more persevering and ingenious than any marine architect of our own days. Birch bark canoes are not so common as dugouts. The tree, the white or paper birch, is found in Canada and the northern United States. Those Indians who discovered that the light, waterproof cork bark could be fashioned into a canoe made a very great discovery, and indeed it was their canoes that made travel or exploration possible in North America. When man began to long for a settled permanent home, it was absolutely necessary to find a way of living in safety. Wolves, bears, hyenas, and other animals were abundant. Neighbors of his own or other tribes were more ferocious and more dangerous than wild beasts. Some Neolithic genius imagined an artificial island made of logs in the midst of a lake or inaccessible swamp. Such were the lake dwellings which persisted into historic times, and which are indeed still in existence in some parts of the earth. The trees were abundant. They could be felled by the help of fire and an axe, and the lake dwelling gave a secure defense. The wood of some of the piles supporting the great villages in Switzerland seems to be still sound, though it has been under water for many centuries. Some villages are said to have required hundreds of thousands of trees. The forest afforded man almost everything that he used: bows and arrows, shelter, fuel, and even part of his food. Nuts and fruits would be collected, and when possible, stored. In seasons of famine, they used even to eat the delicate inside portion of the bark of trees. But as soon as the first half-civilized men began to keep cattle, sheep, and especially goats, more serious inroads still were made upon the forest. Where such animals are allowed to graze, there is no chance for wood to grow, at any rate in a temperate country. The growing trees and the branches of older ones are nibbled away whilst they are young and tender. The days of the forest were nearly over when cultivation commenced. Dr. Henry describes the process of nomadic culture in China as follows: quote, "They burn down areas of the forest, gather one or two crops of millet or upland rice from the rich forest soil, and then pass on to another district where they repeat the destruction." End quote. A very similar process of agriculture existed until the 18th century in Scotland. Thus the forest was being burnt or cleared for cultivation. It was devastated by black cattle, goats, and other animals, and it was regularly exploited for fuel and building every day by every family for centuries. It is not therefore surprising that the ancient forests in Britain have disappeared. Dr. Henry mentions 1 square mile of virgin forest on the Clonbrock estate in Ireland. The Silva Caledonica of the Romans is said to exist in Scotland at the Blackwood of Rothiemurchus, at Achnacarry, and in a few other places. Of the original oak forest, which covered most of England and southern Scotland, not a vestige, so far as is known to the writer, remains today. There are in places very ancient forests. A few miles from Retford are considerable remains of Sherwood Forest, which is forever associated with that genial bandit Robin Hood. One huge oak, called the Major, has or used to have a keeper always on guard, and paid by Lord Manvers, but there are hundreds of aged oaks all round it. Then there is the Knightwood oak, and some other ancients in the New Forest. But it is not certain that these even date so far back as the time of Canute, for so far as the New Forest is concerned, It seems that this was formed either by Canute or by William I. The Saxons seem to have destroyed most of the English forests. In Scotland, oak forest existed as far north as the island of Lewis, in Caithness, Dornoch, Cromarty, and along Loch Ness, as well as in every county south of these. The deer forests and grouse moors, now desolate, whaup-haunted mereland and peat mosses, were flourishing woods of magnificent Scots fir at no very distant period. They ascended the hills on the Cairngorms to 1400 or 1500 feet, and in Yorkshire to 2400 feet. Even in remote historical times, such as those of Canute, the forests had become seriously and dangerously destroyed. This king was apparently the first to artificially protect the woods as a hunting preserve. He was followed by William the Conqueror and other sovereigns. The game preserves of the landed proprietors today are, of course, the remains of the same custom. Fortunately, however, we do not kill poachers or cut off their right hands, and we do not cut off the forepaws of poaching dogs, as used to be done in medieval days. This connection of forests with game no doubt prevented the entire disappearance of wood, but when, as in the case of England, the comfort of pheasants is thought of more importance than the scientific cultivation of forests, the result is often very unfortunate. The use and value of timber is, however, too important a matter to take up at the end of a chapter. End of chapter 3. Recording by Linda Johnson.